In this tutorial, we'll be learning how to deploy NFTs to Ethereum, Polygon, and Binance Smart Chain, all in one click. So to cover this tech stack of what we'll be learning today, we're going to be writing smart contracts using Solidity, as you can see in these two steps right here. Then we're going to write tests for our smart contract using Hardhat and the Ethereum Waffle library. We're going to use Hardhat to deploy our smart contracts to the different blockchains. Then we're going to basically create a React web application on the front end and then connect our React web app to the blockchains using Ethers.js. Let's get to it. So first things first, we're going to clone this repo. Okay, here. I'm going to make a new. Okay, clone. And then you can now, so this is a pre-existing template, so we want to go back to the very first commit. I don't really believe in like making things from scratch. I believe in like just trying to find code that already exists. So I have a tutorial on my website here, and then in this tutorial, basically you can go to the very first commit, and the link will be in the description as well, and you can just do git checkout that commit. Oops. And then we should now be in the first commit, and then we want to basically create a new branch so we're not in a detached head state. So you can do git checkout -b arthouse tutorial. Cool. Now it's time for us to install the packages. Alright, so let's open up our code in an IDE. I like to use Visual Studio Code, so I'm going to do code dot. Alright, next we're going to install our npm packages. So I'm going to open up the terminal in VS Code. Now I'm going to be using Yarn as my package manager, but you can use npm, you can use any other package manager that you want. And so I'm going to go ahead and first of all install the Ethers, Hardhat, and all the different smart contracts libraries which we need. And so maybe while that's going on, we can look at a recap of what our architecture is to understand why we need these different packages. So let's go back to the diagram I showed earlier on. Right, so we can see here that in order for us to write a smart contract and to test it and to deploy it, we'll need Hardhat. So if I get this error, just switch to NVM node version 16. Okay. And yeah, if you run these commands and you see like NVM command not found, you can just switch over by just googling NVM not found, and it'll tell you to install NVM, which is node version manager. Okay, so these are the notes I'm going to be using, but you can find the finished blog post over here. Alright, so next we want to basically get the development packages. And the reason why I separate installing these ones from installing these ones is that if you were to, let's say for example, build a production version, you can basically say that only build the things that we need to run the app. Don't also install packages like these ones that we only need in development for things like testing. Like you see Hardhat Waffle, Chai, Ethereum Waffle, Hardhat Ethers. Whoops, so Hardhat Ethers actually. Yeah, Hardhat Ethers. These are all testing packages that we only need in development mode. So let's go ahead and install those. So the next thing that we're going to do is while that is installed, we're going to now go ahead and add our configuration for our testnets. So if we go to source, you should see a config chains.json file. We can actually just go ahead and delete whatever's in there, and we'll add our own file. So we're going to start off by adding the Ethereum Rinkeby network, Binance Smart Chain testnet, and the local host, and we'll add Polygon later so I can show you how easy it is to add a new chain. If you want to add other chains as well, for example, you might realize that actually, and yeah, so like these marketplace addresses should actually probably be blank, so you feel free to delete those. Okay, cool. Our packages have finished installing. These addresses should be blank, but you can just leave them like this for now. If you want to add a new blockchain, the things that you really will need to add: network name, chain names, currency symbol, you should already know. This one you'll figure out when you deploy your smart contract, which we'll get to later. Is mainnet, you can figure that out. Logo URL, you can get that from Google. For chain ID, block explorer URL, and RPC provider URL, there's a website that I like to use called where is it? Chainlist.org. right? So that's another thing I forgot to mention as well. If you need to get the chain ID as well, block explorer URL, and then RPC provider URL, you can use things like Chainlist. If you want to use a block explorer, a lot of blockchains will have like a public available RPC URL, which you can use. But everyone is using the same URL, so it can get rate limited. It can end up being super slow. So what you probably actually want to do is you want to maybe sign up for something like Infura or QuickNote or Alchemy and get your own private URL. And there's another tutorial covered by Nader Dabby that kind of shows you how to do that. So you can either use like the publicly available URLs, or you can get your own. So there you have it. So those are the 3 blockchain networks you've set up. Okay, next thing we're going to want to do is we are going to want to get a private key. So you'll see in the share.env file, there's this thing called private key, this variable called private key. In order for us to get a private key, we will need to use something like MetaMask. So you can go to metamask.io and install MetaMask. And then once you've installed MetaMask, you go through those steps of installation. Okay, so in your MetaMask account, you will want to go ahead and go to account options, account details, and you want to click on export private key. And then that will give you the private key that you're going to use to deploy. And then you can go ahead and just put that private key. You're going to need to make another .env file. So this is not actually where your env files would go, because this is checked into version control. You're going to make touch.env. And this .env file is where you're going to put your private key. So export private key, and then you can put your private key in here. All right, so next we are going to go into our hardhat.config.js file, and we're going to take this piece of code here. Okay, so there's actually been some code changes as well. So we are going to go to hardhat.config.js. We're going to use this piece of code, and then we're actually going to rename our variable from private key, just to because what you'll find, and I'm going to show you later on, we're going to be dealing with different accounts. So it's good to be just explicit that this is specifically the smart contract deployment private key, not just any kind of private key. All right, so now we have our hardhat.config.js file. Let's walk through what these different lines mean. So this basically just tells us the version of Solidity that we're using, and you can go to contracts and let's just say nft.sol to see that it matches up. Yeah, it's kind of off by 0.1, but I guess it's not that big of a deal. This is just an optimizer setting, not super relevant to us. This is where the artifacts are saved. So next, this is actually the really relevant part, RinkB and BSC testnet. So this defines the URLs that we will be using for our RPC, which, if I understand correctly, these is basically the nodes that we'll be using to talk to the blockchain directly. And then so the chain ID, like I already explained how to get that, you can get that from Chainlist. And then the private key is your account private key you got from MetaMask. So RinkB or Ethereum has a couple different blockchains. So the question is, why did we pick the RinkB network? Why didn't we pick something like Ropstein? And then so it's because, well, the simple reason is that because OpenSea supports RinkB. And therefore, if we want our NFTs to show up on other NFT marketplaces like OpenSea, I think Rarible, they all use RinkB as well. So if we want our NFTs that we're making the testnet to show up there, we need to use their blockchains as well. Ropstein is one I used in a different tutorial, how to add Ethereum Binance payments to a React website. And the reason why we chose Ropstein for that one is because Ropstein is actually the one that most matches the Ethereum mainnet. So this isn't super relevant to know, but it's just good to have it as like background knowledge. Ethereum mainnet uses a proof of work until we merge to proof of stake. Ropstein also uses a proof of work, but that also means that anybody can mine it, so it ends up being a lot slower sometimes. RinkB, on the other hand, uses a proof of stake mechanism, so it's not like a one-to-one exact replica of what the mainnet will look like, but it's very similar. It's a very similar mechanism already as well. And then only a certain group of people can mine this blockchain. So that's just some useful background information for you to know. All right, so we have our configuration chain. We have our Hardhat configuration. Now it's time to start writing some smart contract code. So next we're going to code the smart contract. And like I said, there's no point rewriting a smart contract from scratch. And also because due to the security concerns of an Ethereum smart contract, you generally want to use pre-audited libraries that have been audited by other companies. A good example of this is OpenZeppelin. So this is the this is the NFT smart contract that was taken from the Nader Dabit tutorial, but we're going to make a couple changes to the smart contract. And I'm going to go through each of these changes line by line. But I think first let's look at the Open Zeppelin smart contract extension to get a better idea of what they've already implemented for us. And we're just going to basically add some additional features. The first feature that we're going to be adding is, so first of all, let's look at what Open Zeppelin contracts library is. What it does is that it takes the ERC 721 standard. So again, this is just more background information that might be useful for you to know. When a change is made to the Ethereum blockchain, it's first of all that goes to what's called an Ethereum improvement proposal, where basically a bunch of people say, hey, why don't we create non-fungible tokens? We have fungible tokens, which is basically like $1, where $1 is equal to another $1. Why don't we create something that's non-fungible, whereby one Bored Ape is not equal to another Bored Ape? So they go ahead and create a specification and say, hey, this is what we're thinking. Then people can basically give issues, give feedback, leave comments on that standard right here. So you can basically see here, a lot of people will like sort of give their own 2 cents on the issue. All right. And then eventually, if it gets approved, I think it becomes an ERC. I'm not too sure on that actually, but I think is that if it goes to the IP and it gets approved, then it becomes an ERC. And then people like Open Zeppelin will basically look at that standard and actually implement the functions there, right? So if you look at EIP, they'll say things like, so they'll find an interface, they'll see like it should have a transfer event, an approval for all, a balance of, but they won't actually define it. They'll leave that up to people to do themselves. And then you'll have people like Open Zeppelin that will basically go and then implement all these different things that were specified in the ERC proposal. So this is the ERC. So essentially our NFT is already inheriting all of these things from ERC 721 URI storage. ERC URI storage, basically what this means is that when you see a picture in an NFT, it has basically a URI, which is a URL that's pointing to an off-chain location where that image is stored, and people will typically use IPFS like we're going to use. And in order for that to be possible, they basically make an extension to the original ERC 721. So essentially, if you can imagine it, we are extending ERC 721 URI storage, and ERC 721 URI storage is extending ERC 721. So the original function, which we can maybe undo to look at what it was here, had this thing called set approval for all. So what the original contract was doing is that it was tying an NFT onto a specific marketplace. So this basically means that if you make an NFT, then this one marketplace can basically move it whenever they want. We want to basically decouple the NFT from the marketplace, which basically means that we want to allow people to make an NFT on our website and then have it unrelated to the marketplace on our website. So this is a big part of like data portability, giving people the ability to make an NFT on one website, but sell it on any website we want. So we're going to remove the set approval for all. And then we're also going to emit an event called NFT minted event. The reason why we want to emit this event is because if we end up using something like GraphQL can basically, it's basically like a caching indexing service. So if we emit an event, then the GraphQL service will know that we just made a new NFT and they'll add it to our own index. So that when we need to get data, we don't need to query it from the blockchain. We can just query it from GraphQL. Okay, so that is the smart contract. Okay, so if you get any weird errors like file import callback, even if you don't get an error, I think it's always good to have extensions that support your language, especially with something like Solidity. That's a very new programming language. So if you just search Solidity on VS Code, but I'm sure other things will have the same thing. I generally like to go with the ones that are most popular. So the Solidity one by Juan Blanco is the extension that I use. So that's what's able to help me with like, if I make like a syntax error, it'll usually catch that. Like if I change, like if I swap these two, for example, it'll usually complain. Yeah, see, so stuff like that is what it's very useful for. All right. Now it's time for us to add our tests. Testing is always important, but it's especially important in the world of smart contracts just because there is so much at stake. The code is immutable, so it's, coding is always important, but sometimes you don't, write tests like we should. Testing is always important, but sometimes we don't write tests even though we know we should. With smart contracts, you really, really need to make sure you are writing tests. So we're going to go ahead and make a new test. So we're going to go touch source test, and we're going to call this nft.test.js. Oh, whoops, no, it's not there. So now we've just created a new test file. And then in our test file, we are going to just go ahead and write a couple very simple testing cases. So first of all, we're going to be importing our libraries, Chai and Hardhat. You don't have to do this, but sometimes when you're looking at code, you're wondering, okay, where is this thing coming from? It's helpful to have these things here. The default URI. So before we run each of these tests, some syntax stuff. I guess we don't need this. Okay. So let me fix that as well then. Okay. So before we can run any of these tests, we need to basically mock the deployment of our smart contract. So Ethers is super cool. It basically allows us to get access to a contract factory, which basically is like a JavaScript representation of our contract. And so we basically deploy the contract, and then it returns an instance of a smart contract, wait for it to be finished deploying, get the address, and then again, we're going to get signers. So what get signers basically means is, think of it as an account, an EOA, externally owned account. I think that's what it always means. But yeah, so the idea here is that we want to get access to an owner signer. So this is the owner account that deployed the smart contract, is always the first one. Then this is going to be basically the second NFT account, and then the rest are going to be basically put into an array. And so the first test we have is, and this is why I recommend using the Waffle library, is that it allows us to run very, really good tests that are like directly implemented, that like, it basically allows us to test our smart contract logic. So this one is, I think, due to the Waffle plugin, we can use things like create token into emit. Yeah, so things like emit events and all that kind of stuff, we can test that due to Waffle. So the first test is going to basically be, we're going to describe our create token function, then we're going to emit an NFT minted event, and we're basically expecting that when we call create token, so NFT.connect basically means that pretend that our signer is calling this one, call the create token, and then expect and basically ensure that it emits the NFT minted event with the correct arguments. And then you can see this one is a similar test where that when we create an NFT, we are expecting that the number of tokens in this NFT will increase by 1. So to change balance, token balance is basically going to check that total supply or something like that is increasing by the correct amount. So first of all, we create an NFT as an owner that deployed it. Then we're going to create an NFT as the regular user, as like a random user. And then we're going to basically ensure that both times the total number of tokens increase by 1. And then to verify that our test works properly, we can do npx hardhat test. And then we can even just test that specific file by doing something like grep. Okay, so I didn't put my private keys yet, so I'm going to go ahead and do that right now. So I did something else. Okay, so what I did is I've actually put my private key into another separate file, so that way it's not even, because we're going to end up putting other environment variables in this file, so I don't want my private key to be with them. So I'm put that in even another separate file here called .private key, and I've added it to the git ignore file, so it's not checked into version control. So now if I run source.env, it should work, and then now we should go ahead and run npx hardhat test. And there you have it. Our test successfully passed. And if you want to run all the tests, you can basically remove the grep, and then it'll basically run all the tests that you've created so far. Now it's time to add the marketplace smart contract. So this marketplace smart contract has a lot of things going on. And so what we're going to do instead is we're going to simply focus on the parts that maybe are different from the existing Nader Dabbit tutorial, which I mentioned earlier on. So you can use the link in the blog post. If you go to the marketplace smart contract session, there will be a link to the most recent version, and we can basically use this link here to get the code that we'll need. And then I'm going to go through some of the key parts. Now, as you can probably see here, there is about 246 lines of code here. I'm just going to be highlighting the parts that are different from the original tutorial. So some things you'll see is that in the original tutorial, for example, listing price is a fixed number. Actually, let's backtrack for a bit. So at a high level, this marketplace smart contract will allow you to do 4 things. list an item for sale, sell the item, buy an item, and then unlist the item. And so now the selling and buying process is going to be a bit different from the Nader Dabbit tutorial. So let's just go ahead and paste this now and go through the differences in the code one by one. The first thing is that we're going to give the seller the ability to unlist an item. So this means that if they decide they don't want to sell it anymore, they can take it back to their account. Instead of paying a listing fee, we're going to charge a fixed commission. So you can probably see this line right here. Originally it was like a fixed number of 0.025 Ether, except now we're going to basically do it 2.5% on each sale. And then finally, instead of transferring the money directly to the person who sold it, we're going to do something called a pull payment strategy, where you're going to accrue like the amount of money that you sold to a credits, basically hash table, and then you can basically pull that amount to when you want to receive it. And I'm going to explain all of these things in more detail later on. So first of all, let's start with the simplest one, which is basically the switch from a percentage. So when we switch from a fixed number to percentage, we're going to be using, you'll notice here, we express it in basis points, which is basically being, it's out of 10,000. So 2.5% is basically 250 over 10,000. And then when we calculate the percentage point later on in line, in line 144 and 145 here, you'll find out what we do in order to get the percentage that the market takes versus what the seller takes. We multiply the price by the sales fee basis points and then divide. This way we always have a whole number. We're never dealing with decimals because Solidity does not support decimals or floating point numbers. So then we take the market payment, and then to get what the seller receives, instead of multiplying it by like the other percentage, so like 98.5%, we just subtract what the price was from the market payment. That again, because we're like, now we don't have to worry about dealing with all these remainders and all those things like that. So this is one of those nuances that you have to be very aware of. That's very unique to Solidity, is the fact that because it doesn't support decimals, you have to be very smart about how you deal with arithmetic. So now let's talk about unlisting a market item. So essentially, when we unlist a market item, this is probably maybe the simplest way to start understanding React, how to read a Solidity smart contract, is we find a function and look at what they're doing. So unlisting a market item, essentially what it does is it does a couple things. First, we have to make sure that the person who's sending this request is actually the owner of that token. Then we basically send the owner back to the person who sent the message, and then we call this wrapper bridge. Basically, think about this as this basically gets or creates an instance of the IERC 721 and then calls the transfer from function on that NFT contract. And the NFT contract here is going to be an address. So basically call the transfer from function on the smart contract that is at address NFT contract. The reason why we're able to transfer this is because, as you're going to see later on, that set approval for all that was originally here, and then we removed it. What we're going to do instead, we're going to call set approval for all in the front end instead. That way, instead of automatically setting approval for all when we mint the smart contract, we're going to do that when we list it for sale. So kind of we only ask for the permission when we need to. One thing to keep in mind is that this does mean that a given token, like let's say I list an item, unlist and unlist it again, that's one token ID can have multiple item IDs in our ID to market item table. However, we would just basically take the most recent one in order to figure out whether or not an item is for sale. Okay, so next we're going to talk about creating a market sale. And now this part is a bit more involved, so I'm going to walk through each one step by step. So one of the first of all is like, why did I switch from a percentage base? I think percentage base scales better when you're supporting different chains, when you're supporting future use cases where maybe let's say it's like 1 ETH, right? Maybe 1 ETH 5 years ago would be a really cheap price. Now 1 ETH is like $7,000. Even if you make let's say 0.005 ETH. With deflationary currencies, that could increase over time. So with the commission-based model, it scales better. One thing to keep in mind is that even though it might say Ether, but you own it on Binance Smart Chain, Ether just basically means whatever that native token currency is. Just another, maybe one more side note before we dig into the code a bit more is EIP 2981. So another cool thing that we can basically add in is the ability to give royalties to the original minter. So we can basically create something whereby you mint a smart contract, and then every single time that smart contract is sold, you also get a percentage of it. So for example, like let's say you put a 5% commission on it and you sell it for $100. You know, the marketplace, so in this case, our house would take 2.5%. They take $2.50, and you can now say, I'm going to take $5 from that, so that even if people resell it again in the future, you're still getting a piece of that revenue. And so this proposal basically talks about implementing that. All right, so now let's start to walk through the code. And then we will basically start with reentrancy attack. So let's walk through the create market sale code and understand what's going on here. So the first thing we need to look at is this thing called non-reentrant. And so non-reentrancy is basically protecting ourselves from functions that could recursively call each other. So for example, like this could happen where, let's pretend we had moved this function from here to let's say here, right? So what could theoretically happen in this situation is that if we didn't have a reentrant guard here, and let's pretend instead of this was allowed for poll. So let me actually just comment out. Yeah, so let me pretend I commented this out, and let's say we transferred it to the user, and then instead of us doing allow for poll, we called a send, right? And we sent the money to the item owner. Okay, so just bear with me for now. Imagine if we had changed our code to this and we had removed the reentrant guard. Okay, so what a reentrant attack is that a function that recursively calls itself. So this NFT contract address might be a malicious piece of code, and then this NFT contract could potentially also call create market sale. And then so what could happen here is that we would say, okay, transfer, we could even do this to make it even like really worse code. We could basically make a piece of code that after the person has been transferred the money, so like basically give this market owner this amount of money, right? Then what could basically happen is that this transfer from function, again, we don't know if this NFT contract is necessarily safe. So when we call this transfer from and the other smart contract, this NFT contract might have overridden the implementation of transfer from to call our function again, right? And so then basically what you would have a reentrant attack where the code would stop at line 152 here, call our create market sale function again, run this piece of code, transfer the money to them again, because remember, we haven't updated all this state yet, right? So we haven't updated any of this state yet. So we could actually basically freeze here, call itself, transfer the money, call this contract again, which again is malicious, freeze here again, and just basically call itself over and over and over and over again and drain all the money in our account. Maybe a diagram might be helpful here. So to illustrate it again, basically what we would have is that we'd have, again, this is like really bad code, so don't do this, but like this is how an attack happens. So basically what could happen is that our code sends the money to the owner of the item. Okay, now we've paid the person who, who sold the item, who listed the item for sale. Then we're going to call transfer from. Then transfer from is going to basically call our NFT contract, which is maybe over here. Which again, we don't know with this contract is implementing transfer from. So we're trusting that it's implementing it the right way, but it may not be. That's the thing about programming and stuff like Solidity, right? You can't assume that the code is not a malicious or bad actor. All right, so this is what could essentially happen. We could call, so remember, if we remove that reentrant guard function, right, non-reentrant modifier, we could call create market sale to sell an item. Create market sale, again, this is what the code would look at if it was bad code, would say, okay, you sold the item, let's give the person who listed the item for sale their money, cool. Then we're going to call this transfer from function, and we're going to go to this IERC 721 contract. So we go to this contract, right? And then this contract here basically can now call transfer from again. So basically transfer the token. So basically we're calling transfer from at whatever the smart contract is at this address. Now this transfer from could be a malicious actor and call create market sale again. Right? And so then you can imagine, because this transfer from happens before we've updated the state, when we check here to see the owner, this test is going to fail. It's not going to show that the item owner has been updated yet, right? So because of this, it's going to basically call itself recursively. So it's going to send the money to the owner, call the transfer from function, go to the NFT contract at that transfer from, call the transfer from function at that NFT contract, which is a malicious actor that calls create market sale again. And you can have a loop like this that goes on and on and on, and you can literally drain all the money at once. And actually, one of the biggest hacks in Ethereum ever was the DAO hack. You can basically read more about it here. But essentially, the DAO hack was basically one of the very first decentralized autonomous organizations. And then they basically had $150 million or so drained from there due to hacks and the vulnerability in the code base. And that hack was a reentrancy attack. So this is why, smart contract security is so important. If you want to learn more about this, there is a very good paper that was written by a group of people from, I think, Ryerson in Canada, which I think is now Toronto Metropolitan University, that essentially talks about, essentially what happened and how to identify reentrancy vulnerability. So again, not super important to know to what we're trying to do today, but this is all good background knowledge to know as a software developer. Okay, so that explains the first piece of code in the smart contract line. The next thing we want to do, so now we're going to talk about all the different ways we can basically prevent reentrancy attacks. So the first one is by adding a non-reentrant modifier. The next thing we can do is what's called a check affects interactions design pattern. And essentially what this means is that when you're structuring the order of way to do things to do in your function, you first want to check that this action can be performed, which is going to be seen here as the required. So this essentially is that making sure that the owner of this item is the smart contract, and that the amount of ether that's being sent is equal to the price. The next thing that we want to check in this function is the effects. So this effects basically just means that update state internally first. So let's actually go ahead and undo all the stuff that we just hard coded here. Yeah. So next thing we're going to do is update state internally. So effects basically means that anything that's internal that doesn't require us calling an external function, external smart contract, we do that next. So this is things like going to allow for pull, which is here, and then updating the credits balance, right? So that's again internal state, we can do that. Things like changing the item to market ID, changing the owner, changing whether or not it's sold, incrementing items sold, and then also doing another allow for pull call. So that's the effects. So that's basically doing the internal state effects. And then interactions is basically checking to make sure that anything that involves calling an external smart contract, we do that at the very end. That way, if it gets blocked or if it tries to do anything malicious, it's less likely to affect our code. So again, these are all back things like good practice to write in your Solidity code. And then finally, what we want to talk about here is, so we've talked about check effect or entry tag. I put some more links to learn about that. Is pull versus push payments. So in most functions, when it's time to send someone the money, they would usually do something like, send it to the user directly, right? Which is what the original code had. If you can maybe see it here. Yeah. Payable owner.transfer, right? So there we would just directly transfer the money to the person. There's a couple problems with this. First of all is that the smart contract, that the person that we're sending the money to might be a malicious actor, and so when we call to transfer them the money, they might do like weird random stuff and then they can't receive the money. The other problem is that the contract might run out of gas, right? So if the contract runs out of gas and you can't send anybody money, then the function could be basically, then you could basically run into issues, like the function could revert. So by moving from a push to a pull payment strategy, you're moving the responsibility of withdrawing money from the smart contract to the user, who's incentivized to withdraw that money because, again, they want to receive the money for their sale. There is a really good document here that talks about, why to use pull versus push payment strategy. Another thing that I would want to highlight here is, so basically how it works is that when you make a sale, so when you call create market sale, allow for pull, which probably could be renamed. Yeah, it should probably definitely be renamed, actually. Like, I think they called it allow for pull. That's why I did that. Yeah, so allow for pull is actually probably not the best name, but anyway, so allow for pull, you go in here, and it essentially means that for this given receiver, so for this given address, they're entitled to receive this much money. And then when they want to take this money out, they can essentially, actually anyone can call this function, and then whoever called that function, you will have however much money is owed to you sent to your account. And again, this also is a check effects interaction. So first of all, it checks that it can be made, then it updates the state internally, and then it transfers the money. So that covers what you need to know about writing the Solidity Marketplace smart contract. The other things are pretty self-explanatory as well, but the bulk of it is in the unlisting the market item, creating the market sale, and then listing a market item as well. If you want to see alternative ways of implementing, the payment splitting function and the pull payments function, I recommend checking out the OpenZeppelin docs. I think it's seeing how other people have implemented functions is a great way to also level up your skills as a smart contract developer, because there's just so much to learn in this field. So yeah, you can see how they implement payment splitter. They use something like a shares model, which is kind of pretty similar to what we're doing as well. Then they also have a interface or a contract or utility for doing pull payments, and they also have really cool stuff here about escrow and all that stuff too. Okay, so now it's time for us to start writing our tests. So similar to what we did for the NFT test, we're going to do touch test market.test.js. Yeah. All right, so let's look at what kind of test we're going to be writing for our marketplace smart contract. So if you go to the website where this thing is posted, I will create a snippet that you can use. Actually, wait, I think it's already here. So by the time this video goes live, there'll be a link you can click on that will have all this stuff for you. In the meantime, we will just implement it ourselves. Okay, describe create market sale. So if I'm not mistaken, it should basically be describe market function. Yep, that's it there. That's a name this function. Okay, and before each contract is called, we do that, and then we can move this into this. Okay, and then let's look at how it is implemented in nft.test.js, where we have a big describe, and inside describe we have different functions. We have a before, okay, and then probably what we need to do somewhere is, yeah, like let market and all that stuff, similar to what we did here. Market address. So you can see it's very similar. Market sign there. Then we have owner sign as the other sign. Okay. Whoops. All right, so it looks like we have everything we need. So what's going on here? The first thing we need to understand is that before each of these describe tests get called, and each of these describe tests can correspond to, in our situation, a function, we want to deploy our market contract, get the address, get the person who signed, get the signer of the marketplace. So this is different from the person who deployed it, but like the actual account that represents the smart contract. Then we want to basically get the NFT contract as well. Now, in theory, in a unit test, we shouldn't be testing the NFT because that's like a separate test. But I think for our purposes, it's okay because we're writing both, the NFTs and the smart contract. And I guess, and at the end of the day, like this marketplace basically depends heavily on NFTs. So it makes sense to test both together. Like it's hard to test the marketplace without also testing, the NFTs itself. Alright, so I think that covers everything that we need for this, for setting up the tests. So basically this means that before we run each test, we need to basically deploy a marketplace contract, deploy the smart contract, and then the NFT smart contract, and get a bunch of like users. Basically, it's like initialization. So for this scenario, we're just going to test three basic things. If you go to the full source code, you'll be able to find a lot more. So yeah, if you go to Arthouse in the repo and you go to test contracts, yeah, you can basically see all the different tests. So what's kind of interesting about this is that there's 261 lines of testing, and then if you go to the contracts, there are 246 lines. So basically our test is longer than our code, and that's actually normal for Solidity. I think even in programming in general, but it's just something that I kind of found interesting. All right, so next we are going to go through the different test cases. And again, due to the beauty of waffles, it can make our life a lot easier. So for example, like here we are testing that. So I added a little helper function as well, which I probably need to also add to the examples. So yeah, so probably, yeah, by the time you're running this code, we should have all these things available to you, so you don't have to worry about that. And you can look at like the comments I left as well as to why we need these. Okay, so what are we testing at each thing? So the first thing that we're testing is that we want to test that when we update the seller and contact token balance will list an item for sale. So first of all, basically what this is, so remember what I said here, we need to call set approval for all. So this shows that when you create a market item, the amount of tokens that the seller signer or the seller account that listed it for sale should go down by one, right? Because like you listed something for sale, like, so it should show that you don't have that item anymore, or your total balance should decrease by one. And then it should also show that the market account has increased by one, because now you've given it to the marketplace to say, hey, sell this for me. This is basically the same test, but now on create market sale. So this is create market item. This is create. So technically, again, like this is small nuances, but this one is actually testing create market item, not create market sales. So, but I think the idea here is that like in order for this test to work, this test also has to work. But yeah, just something to be aware of. And again, the change token balances is coming from the waffle thing I showed earlier on. Here again, something similar. When you basically buy an item, it should show that your Ether balance has changed by a certain amount. Because of gas fees and all that stuff, this test originally is actually really hard to test. Like just by doing like maybe get the balance to subtract, just compare those two balances together. And also because if your tests are running in parallel, that balance might not actually might have changed between, like 2 or 3 different function calls. So change Ether's balances basically makes it super easy for you to test your code by basically providing a lot of wrapper functionality. Just like a random side note, and what kind of when I talk a lot about sort of looking into the source code of the things that you're using, you can sort of learn a lot of interesting things. One thing that I kind of found super cool was that if ERC 721 and ERC 20, so 721 that's the NFTs, ERC's 20 tokens, that is like basically the like normal currency that's basically interchangeable with each other. They both have a balance of function, and so the same way that a token like maybe like USDC or BNB has an address and you can call balance of to see like what's the total supply of that currency, NFTs also have a balance of. And so if you look at the Waffles.js source code, you can actually see that it's calling balance of. And so because of this, like Waffles doesn't even need to know if it's an ERC20 token or ERC 721 or ERC 1155. As long as it implements this balance of function, it will work. And so what's kind of funny is that sometimes when your tests are failing, it'll be like, oh, it doesn't have one way or two way, which it's like 1/18th to the 10 to the power of 18th of a decimal place, but it can also work as like an integer number for tokens, which is kind of cool. All right, so with that all being said, we've added our tests. Now let's go ahead and run these tests. Now, first of all, whenever I like to just test the specific thing I've changed to kind of save time, because that we see if there's obvious bugs that have been introduced. So we're gonna just go to one market, I think is the name of our test case. Yeah, I call it NFT market in another piece of code, whatever, it doesn't really matter. So let's go ahead and run the market test. Okay, again, so the private key thing. And actually, let me see what's in nft-test.js. Okay, so NFT market is in here. Yeah, so for our purposes, we are no longer using this test, so we can just go ahead and delete it. Another thing to keep in mind is that whenever you change your smart contracts, Solidity, so yeah, this grind is not defined, so let's just fix that typo. Beautiful. So all of our tests for market have passed, and then now we can basically test, because sometimes too when you change one function, maybe another test will start breaking. So it's always good to make sure that all your tests are passing. Beautiful. So our 3 market tests have passed, and then our 2 NFT tests have also passed. Awesome. The code is done. The tests are passing. Let us deploy the smart contract. Now that we've created our smart contract, we've written tests for our smart contract, it's now time to deploy it to the blockchain. So the first thing that we're going to do is that we are going to create a Hardhat task to do this. So the current deployment script can be found in scripts deploy.js. The problem with this script is that it requires you that if you want to basically deploy to a new chain, you need to I think update the code. Yeah, so every time you want to deploy to a new chain, you have to basically change the chain ID. We want to basically write a deploy script that we can just pass in a command line argument and deploy to new chains. So we're going to use this code snippet right here. And let's walk through the different steps involved in this code snippet. And again, all this stuff, the link should be in the description to this video. Okay, so let's start to walk through what each line does. Yep, so essentially a task is just it's just like a more dynamic way of running Hardhat functions. So our task is going to basically be that it's going to get the chain that we want to deploy to using a passing command line argument here. So then when we run the task deploy NFT, and then we pass in the chain ID argument, and it's going to convert this camel case to hyphen case. So it's going to convert chain ID and it's going to make it into chain-ID. And so what this is going to essentially do is that it's going to basically get that chain, and then if it's the wrong chain ID, it's going to print this command line argument. And then this little thing I did here is a little trick I found from Stack Overflow. And what it does is that it allows you to color your console output. So you can see, for example, here when our test passed its green, this basically allows us to make the console output red if it's an error, and then green if our NFTs are successfully deployed. So if there's no chain ID, or if it's an invalid chain ID, it's going to give an error. Then we're going to get the account for a given chain ID. So basically, in order for us to deploy to the blockchain, we need to get access to a RPC provider, and we also need to get access to a private key that has some gas in it to pay for the cost of deploying our contract. So that's what this helper function is going to do, which I'm going to explain later on. And then it's kind of the same thing where we get an access to the contract factory. If an account is passed in, then we pass that in. If not, we just call this. And then we basically deploy our smart contract. And then the cool thing about this is that once our smart contract has been deployed, the marketplace address key, which can be found in config.chains.json, will automatically be updated. And then once that's automatically updated, because React has a hot reload, our React app will also be automatically updated to this new contract address. And then, so that's the right fault thing. So it's going to basically, that address of the contract we just deployed on line 39, add that to the available chains, which is basically the object we just read from our JSON file, and then write that JSON file, and then write that new object to the JSON file, and then print the address of the NFT, and also print the URL so we can view it on the blockchain. Same thing for the deploying the market, because what you'll find is that a lot of times is that the market code might change often, but the NFT code might not change. So this allows you to decouple them. And then finally, we have a task here that allows us to call multiple tasks. So this one here basically calls so when we call just deploy without the colon thing, it allows us to call first deploy the market and then deploy the NFT. Cool. So the next thing we need to do is we need to go ahead and create that helper task. So let's go ahead to go make a new file called helpers.js. And let's use this code snippet from helpers.js. And if at any time you're trying to run this code and it's not giving what you want it to give and it's not working, you can just go again to the github.com/tech house, and you can just look at the file that you want. So for example, let's say that the one in this blog post isn't working for you. What you can do is you can just go to scripts and look at this helpers.js one and try to use it. And then if you're finding that maybe even this one has been changed so much since what you wanted to use, you can then just go to you can go to the history, and you can see basically different versions of the file. So for example, like when it was first replaced, you can look at it in here and see all the changes that were made, etc. Okay, so let's go to helpers.js and let's add this. Alright, so a couple things are going to be happening here. So the first function, what it does is that it goes to this config.json file right here, and it basically sends it into a JavaScript object that we can play around with. Then we have Hardhat settings. So what we're going to do is that we're going to move all this stuff into our JavaScript file here. So basically we can make it more dynamically, and then these things can be read from config.json or something along those lines. Get network settings. So this basically allows us to find the specific config chain based on passing a chain ID. So this essentially just means that this one, instead of reading from the JSON file, it reads from here. And basically this allows us to get the RPC URL. Because another thing that's kind of maybe needs to be fixed in this code is that this RPC URL, right? It might not always be accurate. So for example, for Rinkby, is that it's using this. So it's basically like this would need to be changed, that like this API key should not be publicly visible maybe, or it should be like in an environment variable. And then so if we need to do that, we can't do that in a JSON file, or it's more difficult to do it in a JSON file. So this allows us to basically put in an RPC URL as an API key. So it's up to you. You can pick whichever option that you want. Yep, so that gets to the network setting. Get provider. So these two functions here are basically tools that allow us to, and these ones was taken from the OpenSea tutorial, which I linked as well, so you can see there for more details. But this one here, so these two functions here, this one gets us access to a connection provider. So this can be something like your Infura, your Alchemy, or a publicly available RPC URL. And this basically is the network connection that we're going to use to talk to the blockchain. And then this account is the user or the wallet that we'll be using to deploy. So this is the one that has the private key, etc. And then export the functions so we can actually use it in places. And then finally, we can go to hardhat.config.js. And so now, instead of having a list of network settings here, it's just going to import all of those from the helpers.js file. And that is now our updated hardhat config.js file. So I'm going to go ahead and commit this now. Like if you're following along, you should be committing this more frequently, but I'm just going to commit this now so we can see the diff once we run the scripts. One more thing that's super important is the environment variable. So I call this a .secrets. .env.secrets, it doesn't really matter what you call it. But one thing that you might need to add is, again, if you try to deploy your smart contract using the publicly available RPC URLs, it might take a really long time, it might time out. So again, I recommend signing up for an Infura account. You can watch other tutorials on how to do that. And yeah, so you can go ahead and put your Infura API key in here. And then let's just go back to helpers.js to make sure we're, Infura API key, yeah. Okay, so I'm going to go ahead and add that now. Yep, so I'm putting in the share.m, but you will put these two files in the .m file, and you're going to put the Infura API key. Yeah, Infura API key, which you would receive from Infura or whatever your provider is. Okay, so now we can load those with source.secrets or source.env. In order for us to deploy our smart contract, we will need to get some test crypto from a faucet. And then the way to do this is by getting crypto from a faucet. So there's a bunch of different faucets. They frequently go down. So you might have to try a bunch of different ones, or you can just Google faucet. So the way you get this faucet is you basically open up your MetaMask, copy that address to clipboard, and then just start cycling through the different ones and see which one will send you ETH. So I'm already logged in here, so I actually can get quite a bit of ETH from this account. So you can see this one here, the website is already down. Okay, so some of these might work, some of these might not work. Yeah, so I think this one doesn't allow us. Okay, so I'm on the mainnet. So this is another thing you need to be aware of. In order for you to see your new balance, you would have to switch from Ethereum network to whatever your current network, your desired network. So for in this case, we want Ethereum Ring-B. So Ethereum Ring-B is already added by default, so we can just go here to get Ethereum Ring-B, and then you see now we can basically get our desired address. Okay. So that's some more ETH. So this one I think the faucet says it's offline. So it's probably only won't work. Let's just try. Yeah, faucet offline, so this one's not going to work. And then Binance testnet, this one usually works. Okay, so now, for example, we've added Binance. As a chain that we want to deploy to. Now we will probably want to be able to see the new networks that we've added in our MetaMask. So now we want to be able to see the new networks that we've added to our MetaMask. So the easiest way to do this is to go to something like testnet for BSC scan, and you can do this for mainnet as well. And if you go to the bottom of the page, you'll see something called add BSC to network. You click on that button and it will basically add that chain to your network. I already have it, so it's asking me to switch instead. But if you don't have it, then it would ask you to do that. And then same thing for Polygon. If you scroll to the bottom of the screen, you can add them on by network. And you can also, and then if you remove this, and you scroll to the bottom of the screen, you can also add the Binance Smart Chain mainnet network. Cool. So we have our private keys, we have our crypto from the faucet, we have MetaMask showing the new accounts, and then again we can go to MetaMask to verify that we've received that money from the faucet. If we go to activity, will it show up here? Okay, so it might not show up in activity, but it should show up once we go to the block explorer. So if we go to Ring-B, we go to activity, yeah, you can see we just received 0.1 and 0.5 ETH. Cool, time to deploy our smart contract. So we can just take this command right here. So let me just actually commit this first. So git commit -a create smart contract git NTM market smart contracts. So of course this should like usually be like split up over multiple commits, but because this is just for testing purposes, it doesn't really matter. Verify to make sure that .env or .private key are not in version control. Git add for the new files. And there you have it. Now we can deploy our smart contract. First of all, let's verify that the chain ID error thing doesn't give it, like if we pass in an invalid chain ID, it won't run. So let's go chain ID foobar. Cool, so it says invalid chain ID foobar, please select one of the following. And this is a result of that line we have. And I think it's both in market and deploy. That basically says invalid chain ID, and you can see it's in red because we added the little characters, the special characters I mentioned earlier. Okay, so that's good. So now let's go and pass in chain ID number 4 to deploy our smart contract to the Ethereum Rinkeby network. That was actually pretty fast, faster than I remember it being. Cool, so it has deployed our smart contract. And so we can go to these 2 links. Okay, so this might happen a couple times. When you see this means that it doesn't actually deploy your smart contract. This is using the local host network type thing. So it's not actually deploying the smart contract we want. So if this happens, it usually means you didn't load in your environment variables properly. So I'm going to run again source.env. Okay, let's try that again. So just to clarify, the reason why we know it didn't deploy to the correct network is that if you click on either of these 2 links, you will find that there's a bunch of other random transactions here, and they don't include our transaction, so which tells us that this is using someone else's contract. Most likely what happened is that we're using the default private keys instead of our own specific private keys. So sometimes deploying, you'll run into really random weird issues. So what you can do is you can basically also preserve the default Hardhat script, and then if your new deploy task isn't working, you can just fall back to that one, which is what we're going to do in this case. We're just going to make a new file called deploy-hardhat.js, and then we're going to just copy this command, which is essentially the command we had before. I like to put lots of comments in my code. Cool. And then now if you want to run this, you'll just pass in npx hardhat run -- network scripts deploy.js. So I actually prefer to put the command line arguments at the end. Oh, no, that's not going to work. We need to change it to deploy-hardhat. To remember, we have 2. And again, deploy-hardhat is actually probably not the best name because technically they're both deploying using hardhat. So maybe we want to call this like deploy default or something. But for now, we can just keep it as deploy-hardhat. Usually if it's taking a longer time to run like this is usually a good sign because it shows that it's actually deploying to the network. I can now set property and NFT macro. Okay. Okay. So this is something super important to keep in mind. So one of the problems with this is that, okay, so actually we can actually fix this. But then why did it take so long to run? Oh, damn. So this is another thing that's crazy. So the contract actually ended up deploying, but it errored out before we got a chance to see the error message. This is actually kind of a waste of gas, right? Like we deployed a contract, and it's not a waste of gas because we could probably somehow find the smart NFT address somehow, maybe, I think. But anyway, the point here is we deployed a contract, it worked, and then it errored out on this line, so we kind of wasted gas. So this is actually something that is super important to be aware of. Make sure you write good code. And again, this is why I moved all this stuff into a task so that, we don't have to worry about doing this. And the error that happened is basically, it reads this chain ID, which we have to set manually, which is why we wanted to switch to a task. So if you don't update this chain ID or use an invalid chain ID, it will error out. So what we can actually do instead is we can move this chain config code to be earlier on. Let's say here. Should probably use a linter tool. Okay, and then what we can do, if not chain ID, and then you say if not chain config chain ID, and then chain ID, and you can say invalid chain ID found. Invalid chain ID found, and we can use string formatting for this. Valid chain IDs include So again, not only so this is actually like a good best practice for when you're writing error codes. Don't just show them what the error is, also show them how they can fix it. All right, so don't just tell them that your chain ID is invalid. Show them a list of what are some valid chain IDs. So let's rerun that command, and then we're going to keep this error bug here by using the invalid chain ID and see what happens. Oh, whoops. This should be if not. So that's another thing too, you have to be very careful. Once you deploy a smart contract, like you're already using up the gas. So if you like do Control C, there we go. See, so invalid chain ID, valid chain IDs include And what we should do to make it even better is that we should actually specify. And so what would actually make it even better is if we could specify what the invalid chain ID was. Because I might be looking at this thing, what do you mean invalid chain ID? Ring piece of valid chain. Oh, it has to use a number. What number is it currently using? Using that number. Right, so again, this is not necessarily super relevant to the code, but it is something good to know for general knowledge. And also another thing people might make is that they might pass in a valid chain ID, but it doesn't correspond to the one that's in the script. So all of these are just basically more reasons showing you why we wanted to move all of this stuff to a task. Because there's just there's so much room for human error when we do things the manual way. Nice. Our smart contract has been deployed to the RinkB network. There you have it. So right now it just got deployed, so you won't see a lot of details about it yet. You can just see things like the address, and you can see there's no existing transactions, which makes us feel like more likely that this is the correct one. And then we can also see the NFT. So if you click on that one, we can also see the contract. We can see that there was a method called 14 seconds ago from this address, which corresponds to our address. And then if you go click on, and if you go, usually if you go to activity, it should be updated here soon. If you go to view account on Etherscan, yep, you can see that we called a method 47 seconds ago, and that made this contract. We called another method 32 seconds ago, and that went to this address. And then by this time point now, so that's the transaction hash. And then so now if you refresh this page, and then if you refresh this page, yeah, so now it changed from an address to a contract, and then similarly from this one it changed from address to a contract. And then usually, like if you give it a bit more time, this will actually show the method that was called. And so it would be the exact same process for deploying to the Binance Smart Chain network. And then you can also see here that the chain addresses have been updated. So now let's do the same thing for the Binance Smart Chain network. And then also don't forget to change the chain ID. So we can go to config chains.json, get this chain ID 97, deploy hardhat.js and change that to 97, and then run our code. Cool. And then now we can also view our smart contract for the Binance Smart Chain testnet. So we can see here exactly same thing again. It got created about 10 seconds ago with this transaction hash. This is the method. And then if you click here, we can also see another one that got created. And if you refresh the page, it should at some point, yeah, so this one got refreshed almost quick immediately, and shows us that it is actually in fact a smart contract that got created at this address. Yeah, and there you have it. So that's how you deploy a smart contract. All right, to see how easy it is to add another blockchain, let's add the Polygon Mumbai chain. So the first thing we're going to do is we're going to go to our scripts helpers.js, and we're going to add the configuration settings for the Mumbai network. Then we're going to go to our config change.json file and copy the configuration settings for Mumbai. So source config.change.json, and we can add it here. And then as you can see, the RPC URL doesn't match the one we have in our config settings, so that's something to be aware of. And then now if we want to deploy to Polygon without changing any of our code, all we have to do now is change it from network, from Polygon from Binance Smart Chain or Rinkeby to Mumbai, based on the name in helpers.js. And remember, if you want to get, if you like, I already have some crypto in my Polygon network, and I also already have it added to my MetaMask. But if you didn't, you can just follow the instructions I already showed earlier on to get some testnet Polygon crypto and to also see it in your MetaMask browser. So if I switch to Polygon Mumbai testnet, here we go. Yep, so I think I have enough here to deploy. So I can go ahead and do dash network Mumbai. Okay, typo as well. Fix that. Oh, whoops, again, see, this is the problem with manual deploys. I have to update this thing to use the Mumbai chain ID. And also, this is not necessarily required, just because of the way that I do the code to make it more dynamic. Yeah, this is why we have to do it. You don't necessarily need to have the chain ID because you don't necessarily need to write the config chains, but because I do it this way, that's why we have to kind of always remember to update the chain ID. There you have it. So now we can see our new blockchain in the Mumbai Block Explorer. There you have it. See, and then we can also see the NFT art. Remember, so if I refresh the page, it should start showing the contract soon. So it might take a bit of time. Okay, so another way to check that your thing worked properly is that if we go to MetaMask and we click on, so yeah, you can see the match number went down, which tells us that it did go through. And if we go to view account in Explorer, we can see that 51 seconds ago, this is the transaction that we made. And if you click on that, it should tell you this contract was created. Now we're going to build a React web app to communicate with the blockchains we just deployed using Ethers.js. So we're going to have three functionalities: create an NFT, list an NFT, and then buy the NFT. And then we're also going to need three components to do this: a crypto price edit, and an NFT card component. And so these arrows suggest the dependencies. So in order for us to create the NFT, we need an NFT card, and the NFT card is going to be using the crypto price edit component, and the crypto price edit will be using crypto price. And to sort of see what that looks like is if we go to the gallery, for example, and we go to list for sale, the ability to set a price for something, and let's say 10 USD, and see that in BNB, that is using is going to be using the crypto price edit. And yeah, if you want to see a demo of what that crypto price edit looks like and what we're going to be building, this whole component is the NFT card. List for sale is crypto price edit, so you can set the price in in USD or in BNB. And then you'll see the equivalent in the other currency. And then of course we're going to put that all together in the create NFT page that will look something like this. Alright, so first things first, let's go ahead and create the crypto price component page, and we can just get that from here. Split terminal. So you can either use terminal or you can use. I generally like to use terminal. Touch source components. And so this line of code is pretty self-explanatory. Most people are still used to intuitively thinking about things in currencies like USD. So I think whenever you show a price in crypto, I always recommend you should always show it in USD as well. So don't just say, okay, this thing costs like 0.05 ETH or 1 BNB. People don't know what that means. Say it costs 1 BNB, which is currently trading at like 10 USD. Right now we're using hard-coded values, but you could use an API, cache it to local storage to make it more dynamic. And next we're gonna make a crypto price edit component. So so this is actually, I call this one crypto price edit, but it should actually be going crypto price edit with its own component. And this just basically allows us to easily switch back and forth between swapping a currency from USD to CAD. From USD to crypto's currencies. Okay, and then final component we need is the NFT card component. We're gonna go to new file. NFT card.tsx. And actually, I want to get the most recent version of this code. And then NFT, so let's start to walk through the different things in this NFT card component. Starting with, so you can see this NFT card is a lot more involved, so we're gonna have to do a couple things to use NFT card. First things first, we're gonna need to define a config chains model. So if we go to config, so when you're running this code and you're getting all these red errors, you can just go to the Attila GitHub page for Arthouse, and then you can just find the missing component. So for example, config chains is missing. And probably what you want to do is I'll have a permalink so you, to basically show you the exact spot at which you should be getting all of these. So yeah, so don't forget to import all missing codes you can find from this blob. So if you go to this blob here, you can just move around. So we can see here we're missing something from config. So if we go up to source, we go to config.ts, we can get the code from there. By the time you're watching this, I probably would have a more recent version. So for now, we can just go here and then use this for our config. And we can see we need to make a model, so that's also missing. So we go to source, models, new folder, new file, chain.tsx. Okay, so let's go back to the NFT card and see. Okay, so it's almost like a dependency tree. So we have to basically fix all the dependency errors here. Okay, so now this one is good. So what else are we missing? We're missing an NFT metadata component. So we go to models, NFT.tsx. And the reason why we call it NFT metadata is so it doesn't interfere with the NFT class, which I'll explain more about later on. So why .ts versus .tsx? .tsx is if there's any components, like React components, we use .tsx. But if it's only like just regular JavaScript code, then we can just use this. And we're also mixing a marketplace display component. So we go here, copy our contents. Couple more things we need to still fix. NFT card.scss. And then I should probably at this time. Okay, so let's fix these errors first. So set list crypto price. So we will not be actually using a couple of these scenes. So we're not going to be using the my nft.tsx component. We're just going to be using create NFT and gallery. So we can just go ahead and delete these two components. And then for gallery.tsx, okay. So I'm going to explain all this code later on, but in order for the errors to just go away, I'm going to just go and put them in now. So source, scenes, NFT, gallery.tsx. Copy that. Okay, we need another component called NFT list. So new file, NFT list.tsx. Okay, so we're actually not going to be using Morales, so I will explain this one in a second. All right, so now everything should be working. App.tsx, okay. So it's still expecting us to use, so we're not using this anymore. So we can replace this with, okay. Okay, that's it, cool. So now our component, everything is working. We've copied all the necessary code. So now we can go to create NFT. So let's look at what's happening in create NFT to understand what we'll be doing on change. So what this function does is that when we create our NFT, we're going to upload it to Infura. And the reason for this is that essentially Infura is a more decentralized way. It's still a little bit centralized, but it's a more decentralized way of saving our images as opposed to just storing it on like a regular centralized server. So when we drag our image over here, it's going to automatically upload it to Infura. And actually, I can just show you a demo of what that would look like. So let's use the Attila.ca logo for this example. Okay, so what this does is that when we upload this image, if you open this image in the new tab, you see that this URL has a special URL, which is an Infura URL. So this basically means that it's more decentralized. So it's distributed over a bunch of different servers as opposed to being stored in one centralized server. But the real magic happens here in this create NFT function right here. So let's go through what all the different things that are happening here. So first thing it does is that it calls the NFT metadata. So this is going to be things like from the URL. All right, so what it does is it installs all the metadata in IPFS as well. Then what it does is that it calls Web3 modal. So Web3 modal basically is what allows us to connect our code to different crypto wallets. So as you see, I've been using MetaMask for the most of this, but you could use Coinbase Wallet, you could use Wallet Connect, you could use a bunch of different providers by using Web3 modal. Then this is the important piece. This is where we get the provider. So in this case, the provider would basically be MetaMask. When we ran our code in Hardhat through the command line, it would be like Infura, Alchemy, etc. Get signer, so this is when it'll ask you to like if you can connect your wallet, and so the signer in this case is going to basically be whatever the current signed account is. If you're not on the correct network, it's going to ask you to switch over to the correct network by making a request to switch Ethereum chain. And then it's going to basically put some UI stuff to let the user know that we're currently loading. And now here is where the beauty of the real smart contract and JavaScript React code combine. The first thing that it does is that it gets, we can programmatically get an instance to a contract, like a JavaScript object that represents the smart contract, the address where this contract is existing, and this ABI. ABI essentially stands for application binary interface, and it's essentially just some sort of, and this is the JSON file. So when you look at NFT, it's coming from the artifact. So if we go in here, we go to nft.json, that's what it is. And essentially what this is it's basically a representation of what interfaces are available to the smart contract in JavaScript. what interfaces are available from the smart contract in JavaScript. So essentially what we're going to be doing here is so essentially what we're going to be doing here is we're going to basically get an instance of that contract. So if we go back to our diagram, so this right here, the ABI is what allows, so this could actually be a two-way arrow, right? Because it's going in both directions, same with this. So what the ABI basically does is that it allows us to talk to our blockchain smart contract through Ethers.js. So this right here says, and the sign is basically be who is calling this contract. So if we were to go to our market.sol contract or nft.sol contract, when we see message.sender, that message.sender value is being populated through the signer. And then so we call the create token function in our smart contract. So let's drag this right here. So create token here corresponds. So we're going to be calling that in our smart contract. We're going to wait for the minting to finish, and then we're going to get the return value. So in our code right here, when we have return new token ID, this piece of snippet, this code snippet right here is what allows us to return the token ID. And then we basically just do a bunch of different things to like format this in such a way that we can now display it in the UI. And that's it. All right, now let's put it all together and create our NFT. So we're going to create the Upweight NFT, which is basically the new Attila logo, and we can get a description from here. We can get the URL from there, and then we can get the image that we need for our thing. Drag and drop it here, and then we can just go ahead and click on Mint on Ethereum Rugby. And see, switch to the correct chain and try again. So this is in our create NFT function right here. When we check the network version and we check the active chain ID, because it's not correct, it's calling because they don't match each other, it's calling the switch Ethereum chain function. And that switch Ethereum chain function is what basically triggers this request in MetaMask. So now we've switched the network, and let's try again. And again, super important, make sure that you are on practice 2, right? Make sure you're using 3 different accounts for this. Cool, that was fast. So we minted it on Ethereum. So we can, and the cool thing about NFTs is that even if you make an NFT on one website, and it's all about, you own this NFT, you own this data. So then you can view that NFT on the Block Explorer, you can look at it on OpenSea, on Wearable, on all these different NFT marketplaces. Because again, it's on the blockchain, it's on a public database, anyone can see it. So now let's mint it on Binance Smart Chain as well. So again, first of all, it's asking us to switch networks. Cool, and then now we can mint it. And also finally, let's mint it on Polygon Mumbai. So we can view this one on the Block Explorer as well. And we can just view this one on the Block Explorer and OpenSea as well. So now let's go through the different Block Explorers. Essentially did the same process. So if you can see here, we created the token about 27 seconds ago. We took it from the burn address to our address. And then we can also see, if you go to contract, we can see that the contract and the tracker. So the contract this was the contract creation code we did together. And then we've already minted it once. And then this is the mint that we just did. Similar stuff on for the NFT we minted on Binance Smart Chain testnet, and similar process for the NFT we minted on Polygon. And sometimes if you've just loaded it, it might not show up, so you might have to refresh the page. And there you go. So now you can see it on OpenSea. You can see it on OpenSea for Rinkeby. You can see our NFT on Wearable. Sometimes your NFTs will not immediately be available for viewing on other marketplaces. This is because they cache the data from the blockchain on their own servers. So usually just wait a little bit, refresh the page, and then you should be good to go. And you can also see it onto NFT Trade as well. And there you have it. We've now shown how you can make an NFT and easily deploy it to Ethereum, Binance Smart Chain, and Polygon. If you want to see what the final version looks like, you can try it out at art.atila.ca, or you can practice with testnets at test.art.atila.ca. Don't forget that all the code used can be found on the Atila Tech Art House GitHub page, and the code can also be found, and all the code snippets and examples and links I referenced today are also available in the blog on Atila as well. So yeah, check it out. Let me know what you think. And then in part 2, we're going to be talking about how to actually list this NFT for sale, sell it to someone else, and then withdraw the money which you've made. Thanks for watching. Have a great day.